and welcome to the SaaS developer community, where we share interesting ideas around SaaS development. And I have a very special guest today, someone that I've been trying to get for months and months, and I'm so excited he's finally here. Sam Ramji, I hope I'm pronouncing it correctly.
Yes.
And he's the Chief Strategy Officer at Datastax. And obviously, just the title makes one excited because you're about to hear interesting strategic ideas. So happy to have you here on the show, Sam.
Gwen, it's such a privilege. I've been following you for a long time, and we interacted a little bit over a really thoughtful diagram that you started having an open conversation on Twitter about data architectures.
Yes,
I've been a fan of what you've been doing for the last couple of years since I joined Datastax. Obviously, your thinking and articulation have been super clear. And then when I got a chance to meet you a few months ago, it's just like, here we go.
yes, so excited. And so when we met a few months ago, one of the things I was especially excited and inspired by is just the story of how you got to where you are, because there, 100% there is no career path to how do one become a chief strategy officer, and your path was definitely just zigzaggy, exciting, full of really cool opportunities in very different kinds of companies. So I just wanted to share a bit how this went.
Yeah, well, thank you. I just feel like the luckiest odd duck. You know, like if you're a certain kind of duck, everybody's like, okay, I want that white duck, right? Or if you're this other duck, you're like, I want that mallard duck. But like when you don't look like any of the ducks, it's like, what do you do? I find that the thing that's true for me, like all through my life, and especially now, as you said, as chief strategy officer of Datastax, is I'm just intensely curious. So I tired my poor mother out by asking why so many times, despite the fact that we didn't have a lot of money. She bought me a dictionary because she wanted me to bought me an encyclopedia um, because she wanted me to get mostly the right answers to my why questions. So it's pretty funny. Like it's been like that ever since. So I just kind of keep asking why, and then I try to figure out like how. And then once I'm kind of satisfied with that, I find that my attention kind of naturally moves on to the next thing I'm curious about. So I got curious about how computers worked. So I started programming in high school, never thought about it as a job. I ended up being the unofficial TA for AP computer science, right? Just like in the 80s, right? So I'm 50. I went to
What
high
was your
school.
first computing language?
Basic, actually. I learned to program when I was 9 years old in fourth grade on it was an 8 kilobyte PET computer, a Commodore PET. And it was Microsoft Basic by Bill Gates and Paul Allen. That's the first screen that you saw when it popped up. Here's the crazy thing: when I was 33, I actually got a chance to work for Bill Gates. And the day that I met him, like I had an out of body experience. Like my brain stopped, my heart stopped, but I had practiced what I was going to say to him in the first minute 26 times just on the drive to work. My cognition departed, and I came back in, and my mouth was still going in the practice that I had been doing. And he was paying attention. It looked like I hadn't dropped a beat, but like I definitely had an out of body experience.
Yeah, I can see that. Bill Gates is definitely out there exciting. I was also kind of excited to talk to you. But please, do you remember the first program that you wrote that actually felt like, hey, it's doing a real thing?
Oh
Not
boy,
hello world.
yeah. Back in those days, you didn't really have media that you could share, right? So I did a lot of programming out of magazines, right? You'd get the monthly computer magazine, and then you'd type in the code, and you'd see how it worked, and then you'd make some changes, and be like, well, maybe it's a fantasy game, and you want to change the characters or the creatures or whatever. So it was a lot of that.
Your games. Oh my god.
The
Yeah.
first program I wrote from scratch on purpose was actually in Lotus 123 for a company that I was working a summer job at in London. And they had 7 different international subsidiaries, and they needed to do monthly roll-ups of their financials. And nobody trusted the programs that had been written, and they didn't know how to automate spreadsheets. So I was like, hey, instead of like doing all the stuff manually, I could write you a program in the spreadsheets themselves that they're sending and have it just automatically compute. They're like, that's too crazy. I'm like, well, give me a shot. And so after a couple months, I was able to build the system. And it was an amazing teaching language. I wish that Lotus 123 hadn't been lost, because you can see in the spreadsheet, like, here's my code, and you could go and inspect the registers, right? You would store your variables and all your data
Oh,
in the sheet. So if the program broke, it broke at a moment where you could visually inspect the entire state of the program. So it wasn't until many years later that I was doing C++ on an in-circuit emulator, right, where you could see the assembly and the C++, and you had all the breakpoints, and you could see what was in memory, and you could create, you could do whatever you wanted. That I had such a good visual environment. So it was few and far between having my first great experience and then having my next great experience was like all of college between that.
do you
Nothing practical, really.
modern things like IPython notebooks can kind of replace this logic
Sure,
experience?
sure.
Anyway, we diverted a bit after I get.
Oh yeah. So, well, I'll just give you like a really short odd duck tour. Right. I've always been curious about thinking. So I ended up in cognitive science. So I studied artificial intelligence and neurobiology and a little bit of cognitive psychology and a little bit of philosophy of mind. And they put it together and called it a Bachelor of Science. I went to UC San Diego. And that was awesome. I got really curious about how do we help people think more. So I went into educational software. So I did, client-side programming, Windows, Macintosh. I worked at Broderbund. Um, Probably the only thing that people would have heard of was the game Myst. I got to work on the sequel to Myst called Riven. So I was one of the 5 programmers on that.
I believe I played that.
Well, now it's on the iPhone, right? You can get it anywhere. All these old games are kind of, all good again. And that began a journey into distributed computing because I was doing this client-side stuff. But the client-side computers that we were, in the software that we were writing in 1995 wasn't particularly smart. So I ended up at a range of different companies, from Fair Isaac doing decision scoring software, distributed systems there, to ultimately Ophoto, where I was director of engineering. And for those people who don't know Ophoto, in 2001, it was a lot like Instagram, but 10 years earlier and worth $950 million less. So we sold it to Kodak, I think, in May of 2001 for like $60 million, which is about what the funding was. So that was the .com bust. And then like we're all like, all right, what do we do next? And I ended up at BEA Systems doing my first non-engineering job. And this is kind of the first big um, leap I took, because all through my engineering career was like, how do I write code? How do I design the code? How do I write bug-free code? How do I work with other people in the team so that we can build these pieces better, faster together? Right. And so I started doing project leadership. And then I was like, there's a lot of really bad managers in the world. And I was young enough to be cocky enough to think I could be a good manager. So I was like, okay, how do you do this? And so I applied this sort of coding mindset to how do I get really good at management? I got into lean thinking by Womack and Jones and a bunch of those kinds of techniques and systems in the late 90s and brought them into engineering management. It was awesome. But ultimately, why was the company that we did such great work at Ophoto, why was it sold for $60 million and not $400 million? I realized I just don't even know if the people in marketing and business and strategy know what they're doing. And how would I know if they knew what they were doing? I could spend the rest of my life here in the engine room and I could end up like who knows where. So I had to go and ask the question. I was really curious. Instead of what we do in engineering, which is how will we build it? I was like, I need to go figure out how do you ask the questions of what should we build and why should we build it? And so that began kind of the next journey through
And
BEA.
how do
And
you get anyone to even use it? Like all
crazy, right?
hard questions.
These are really, really hard problems, right? And yeah, and that's now they call that product management, I guess. But um, I got to work on distributed systems at BEA with big customers and like starting to see these big enterprise architectures, event-driven computing, message-oriented middleware.
Yeah,
And I got
that
to be
was
part
one
of
of
the
the first big commercial ones, right?
yeah, or WebLogic integration was the
Yeah.
project that we built. It grew really fast. It was pretty popular, but I think it was really the fact that we were bold and we believed in XML. So we had this amazing chief technology officer named Adam Bosworth. And in 2002, he had this point of view that all inter-application communication was going to happen in XML. And that was crazy talk at the time, but he was 100% right. But if you wind that forward, you're like, well, why XML? Well, it's verbose, it's human readable. You can effectively stop and debug it, unlike all the binary objects that we used to marshal over the wire and be like, okay, now I have to write an unmarshaller. And every single program you wrote, you had to write your own debugging and observability system. Once you had XML, you can have a common
Maybe
set of
XML
tools.
did not stick, but the idea that human readable is better for developer productivity. It
Yes,
is not, and if you can just get the machines to do it fast enough, then you have a win-win. That
exactly.
absolutely stuck. Like I don't think anyone is going back to binary, making
And
up their own binary protocols.
even if you do a binary protocol, you're using protobuf or gRPC, right? You're
Yes,
using some kind of standardized way that you can generate tools against. But
yes,
really, we were just in this moment where we were bringing XML to message-oriented middleware, and we ended up creating the enterprise service bus market. And so that was just markets generally want to happen or don't want to happen. If the market doesn't want to happen, no amount of cleverness and pushing will make it open up. But if it does want to happen, it will pull a product and it will create a business if you just are humble enough to get out of the way and not think it's about you, right? The world is trying to pull these things forward. So that was pretty
it's
awesome.
true. Yeah.
I got to go to Microsoft after that. I worked in the venture capital group briefly, but then they asked me to take accountability for startup adoption of Microsoft tools for application development and security. And I just I couldn't avoid observing all of the open source that was getting picked up. Right, it wasn't classical competitors that Microsoft understood well. It was this invisible thing. And then I went to this SaaS conference in 2005. It was the first time I ever heard anybody call it SaaS.
Yeah.
It was, I want to say,
Very
March or
early.
April.
I didn't know people use that term,
Yeah,
but
it was like March or April in 2005. It was called the SaaS conference, and amazing people there. Like you may remember, like Stefan Schambach from Demandware. I mean, we're talking really early, kinds of folks. And 8 hours of the conference. I'm like, I'm just eating it up. This is like magic. It makes sense to me based on the sort of photography as a service that I helped build at Photo, and like I could see how this applies to all these applications. But in the 8 hours, they used Microsoft terms twice for about 8 seconds. It was all Linux, Apache, MySQL, PHP,
yeah,
Java. When they talked about anything,
jump
Python was not a
facts,
thing back
2005,
then.
absolutely.
So there was only twice that somebody said, "Oh, and we run this on Microsoft SQL Server. We really like it." So it was said twice. So that was 2 copies of about 4 seconds. I came back and I said, "You know what? You've asked me to look at application development and security. We're doing okay. But where we have a problem is SaaS. These people can't license your software. They don't know how much of it they're going to need. They don't want to talk to a salesperson. Their company's probably going to fail anyway. So you have to get into this permissionless, right? You have to get in this permissionless environment where they don't need to ask for permission. So the first step, Microsoft, is you got to change your licensing and make it free for all these people. You can protect it. You can do term limited. I worked on that program. It was called BizSpark. I think it ended up being the most popular uh, program for startups that Microsoft ever did. But it was only because we were copying some of the core friction reducing ideas embedded in open source. Second thing I said is you got to make all of your stuff work with any open source thing that anybody wants, because that's your opportunity, is to be better together. You can't keep fencing them out. The math is not on your side. So, first they ignored me, then they laughed at me, then they fought me, and then I got asked to be the head of strategy for open source in Redmond, and that's where I got to work with Bill Hilf, who's amazing. He's now the CEO of Vulcan, which is a big philanthropic organization. It's Paul Allen's $13 billion endowment. And then I got to work with Bill Gates, which is Bill Hilf had broken the ground coming from Red Hat, no, from IBM actually, where he was the Linux expert. He was hired across to Microsoft to be the Linux expert. And then I got to work for him for a few years and kind of follow in his footsteps. But because he'd kind of cut the first path, he made a lot of room for me to be bolder. And he this is guidance I'd offer to anybody who's a manager, an aspiring manager. He said, Sam, your job is to change things here. Sometimes that will mean breaking things. So I want to let you know, if I don't hear a complaint about you and what you're doing from someone in PR or engineering or product or marketing at least every week, then you're not doing your job.
This is such an empowering thing to say to someone.
Amazing, right? And he knew my heart was in the right place, and we met weekly. And I'm a detail-oriented person, right? I'm an engineer who does business, right? So I bring documentation and all the things that you'd need. But knowing that he was expecting me to cause trouble, productive trouble, that gave me all the room I needed to really change my life, right? Just step up to a level that I'd never imagined before.
I completely agree. And it's like a lot of managers say, I got your back. And then you have to try a bit and see do they really have your back or not.
Yeah,
But the good ones I always do, so it's not a problem. But saying the opposite, I expect you to cause trouble. It's not even a question of whether or not I got your back. This is take it for granted. I need you to go and steer things up because otherwise we cannot make progress. Is really amazing.
it's extraordinary, right? I mean, it makes you think about metrics and our communication of metrics. Like, what is it the outcome that you want? What are you measuring, and how are you communicating your measurement, right, with the people doing work? And all of that was densely compacted in that one poetic, right, expression that he
You
offered.
have
And I was
not
like,
forgotten
wow,
it for many years
just
since,
insane,
so clearly
just
it
insane.
was a big deal.
Insanely great. So, we got Linux interoperability. I got to work with folks like Miguel de Icaza and Nat Friedman back then because we did a big deal with Novell to do interoperability between Linux and Windows. Worked with folks like Jeremy Allison from the Samba project and just kept looking for every single thing. Like I was not going to sleep until all of LAMP and all of the most popular packages ran on top of or next to Windows. And if we could do that, then we'd probably gotten the company on a good path. What I didn't expect to be able to do was to get Microsoft to commit code to Linux under the GPL.
Which is very
So yeah, I think it was like release 2.6.28 or 30 that Microsoft was the number one contributor because we brought in these drivers in the Linux kernel driver project. And that was the brainchild of an engineer, Hank Jansen, who had previously worked at Bell Labs, a super smart guy who'd worked on uh, System 5, Unix, like R4. He wrote the multi-threading code, and he was just like a passionate open source Linux person. So he didn't even think he'd ever work for Microsoft. And it wasn't until he and I got to talk that he came in. And after doing great work for a couple of years, he had built the credibility to say, I think we need to do this. Here's these things that we've done around libvirt and Hyper-V, and we can make Linux think it's running on Linux when it's running on Windows, and we can make Windows think it's running on Windows when it's running on Linux. And this is kind of magic. That technology ended up being the heart of what they'd built in Windows Azure, and it's why, right, the echo of that code is why Azure runs Linux as it does. But his push to put it under the GPL was exactly what we needed to reform Microsoft's approach to licensing and software engineers and whether or not they could look at open source code. So that was the last meeting I actually got to have with Bill Gates was end of June 2008, just before he retired back then, and he was helping, right, lead us through this reforming process because he knew the power of open source. They didn't let him do much about it. So he very, very thoughtfully used Bill Hilf's team and my team to change the company. And so we were able to change those rules. And now you look at where Microsoft is today, many, many people have done a ton of work since then, right? And it's bigger than anything we ever could have made. But I
mm,
know the infrastructural moves that we had to do and what people believe to be true, how they measured success, how this connected with what developers valued, and the sticky part, how to deal with the licensing and the intellectual property and to not get Microsoft into trouble and to be a good citizen. So interesting times.
and it sounds like you really managed to nail like there was a bottom up push to change things about Microsoft. There was also a top down push, and you
Yep.
managed to kind of align the forces to
Yeah.
really make a difference. Because a lot of times, if it's only bottom up, people just try for a while. It's going nowhere. Gets frustrated. And same thing if it's only top
Yep.
down. Like an executive can push and push, but eventually like if you need to see that people rise up to the occasion, so
Yeah.
it's really nice that you managed to create this uh, alignment.
And it was amazing. As you say, I was not the first bottom up person to care about it and think it was a good idea. But I was the first person to be able to get the top down alignment. And I had this great sponsorship, obviously, from Bill Hilf and from Bill Gates and from Ray Ozzie, but also by an amazing executive at the company, Chris Capicella, right, who really created space and said, hey, this interoperability stuff that you're working on, Sam, like this seems powerful. You should drive it. You should declare it, like make it happen. Such a brief interaction again, right? This is kind of the power of mentoring and executive leadership. He didn't tell me a lot of stuff, but he said it with his whole body, and I believed that I could do it. And so the team came together and we did it, right? So
absolutely.
It
And
was that connection between top down and bottom up to move the company's metrics, change, how we scored things, and that it enabled us to change the behavior of 55,000 people in the field.
crazy.
Crazy, right?
So after Microsoft, you went to Apigee, or were there things
I
in
did.
between?
That was
That
my second
it
time
was
working for Chet
tiny
Kapoor.
company at the time, right? Like Apigee. Oh,
It
you
was
founded it, right? I
Yeah,
mean,
so it's a funny story. I'm working for the same manager again, right? So my CEO, Chet Kapoor, I first met in 2002 when I worked at BEA. We built the WebLogic integration business together along with others. Then I kept trying to get him to come to Microsoft because I thought he was so amazing. I was like, hey, we're trying to make this open source stuff work and win the web and all these opportunities to get things right. He's like, yeah, I'm kind of working on this thing called Sanoa. And good old XML, Sanoa was an XML router.
oh,
It became
no,
an XML firewall. You get out all these rules to it. But it started getting pulled into this direction of like, hey, APIs seem like a thing. And all these XML APIs, we kind of need a gateway, just like we have a network gateway for the binary protocols. We need something for this. And so that's like in 2009. For various reasons, I decided to leave Microsoft, come back to California, and Chet was the first person to say like, hey, there's something really cool here, and let's hang out together. And we got to end up building a public company on APIs. So we took Apigee public in 2015 and got acquired by Google in 2016. I took a quick detour there. I was chief strategy officer at Apigee, and then I got to spend 2 years as CEO of Cloud Foundry, which is an open source platform as a service project,
I forgot this part of your
right?
journey.
Which was super fascinating. So many smart people had put effort into building that. It was Project B29 at VMware. It anticipated, right, this cloud based world, but it bridged what you needed from a cloud platform with what you actually had in the data center, which was a virtual machine, vSphere based environment. From that, I actually got recruited to Google to lead. I was the VP of product management for developer and compute, which means basically Kubernetes, DevOps, compute engine, right? All of that side of the business. Um, at the same time as a whole bunch of people showed up from Apogee because they'd been acquired off the public market at the same time.
So
Like,
you
oh,
got
did you all come together? I'm like, no, I left 2 years ago, but like we're happy to be together. So
that's
I got to learn from just incredibly capable people. I mean, I think the stories that people tell about Google, they're either all true or none of them are true, right? And I will say that some degree of both is accurate. Like super smart, built the biggest scalable distributed systems to the to the nines, right? To the ninth degree of engineering. Like when you start bringing your own submarine cable to lay across oceans so that you can get enough bandwidth, you're doing serious, serious engineering. Data centers the size of football fields, and then software infrastructure to light it up and enable you to run YouTube or ads or like any new set of things that you needed compute and network and data for, you could just get. So I learned a lot from
and
folks like
then
Eric Brewer, right, who is the Google Fellow, and Urs Holzle, the head of technical infrastructure there. Just how these systems worked at scale. I got to see that company after it had been around for 18 years and worked through the kinks. So I was there for about 18 months, but I feel incredibly grateful for the sort of the osmosis, right? How do you run this kind of thing? How do you think about 10x? What does the infrastructure need to look like?
exactly like you learn to you like just I'm saying about the journey from Apogee to suddenly running like compute for Google, and it's from the scale of a small startup doing infrastructure to the
Yes.
biggest infrastructure in the world. It must have been like so much experience just crammed into
It,
these.
it, it was. I mean, going to Cloud Foundry was a remarkable bridge for me, right? Because I got to work with companies that were deploying this at scale, like the Home Depot, which built the whole business on Cloud Foundry, and
They were transforming, right? Like not the first time they're building the business, they move the business into Cloud Foundry almost.
yeah. And the other thing is, as a nonprofit, right? It wasn't, it was seven critical companies. It was Pivotal, it was VMware, it was IBM, it was EMC, it was HP, like SAP, right there, the Intel, right? These were all kind of the founding members, and they all had reasons that they wanted to participate. People who were using it, products that were deploying it. So that was sort of distributed multi-cloud infrastructure. But to be able to see distributed single cloud infrastructure at the scale that Google did it was a new level of mind-boggling.
Amazing. And then you took all this experience and went to Datastax to
Actually, so I took that experience,
it's
and
instant.
I should
Right.
mention a couple of other people. One is Melody McFessel, who was my engineering partner. She's now the CEO of Observable, but she was responsible for the developer and the DevOps systems that kept 44,000 developers at Google productive, which is all it really changed my thinking about CI/CD cycles and ecosystem and integratability. Being able to see how that works at scale and also get a kind of a picture of the future. Like we built something that was little bit like GitHub Copilot internally long before, right? And then I was in the deal development process. I was one of three people who was driving the GitHub acquisition for Google, which obviously, as you know, we failed. Microsoft beat us, but it was fascinating to get to know the GitHub folks and just this kind of gets back to what is strategy. Take a look into the future through the few things that we can measure, right? This idea that the future is already here; it's just unevenly distributed. You can really get a pretty good glimpse of 3 to 5 years in the future if you're looking very carefully at the cutting edge. So I went from there to Autodesk, where I ran the cloud platform for the world's largest engineering software company. That was really cool because they really knew that they needed cloud platform competency, and they really liked the idea that I'd be bringing some of these ideas from Google. The things that I brought from Google the most actually were things I learned from Benjamin Trainer, and Ben was the creator of SRE, right, Site Reliability Engineering, or as some people now call it, Systems Reliability Engineering. That way of thinking and the set of practices actually ended up being kind of my transformative watchword to say, like, we need to be an SLO based culture. Let's keep focused on the customer. What are we measuring? What's our transparency look like? And start to change the organization and competencies of the company. We happen to use a tremendous amount of Apache Cassandra. So I got a call one day saying, hey, there's this really cool company called Datastax that is the Apache Cassandra company, and they're looking for new leaders. Would you be interested? And I found out that my old friend and boss, Chet Kapoor, was in the CEO running. And we had a talk, and he was like, why don't you come help me build this? And I thought, this sounds actually pretty awesome. So let's give it a shot. So, almost 3 years later, here we are.
And clearly, you guys are an amazing team. Like, it's the third amazing thing you guys are doing together.
It's all about trust, right? And I think many of us join Chet, like people join any CEO again and again, it's because we trust them and we trust that their intent is good and that their habit is that they create great teams. So when I'm in a team with Chet, or when I think about other leaders that I'd go back to work for again, they have one really consistent hallmark, which is I don't know who I'm going to meet who is also going to be working with them, but they're going to be amazing. We're going to get along really well, and we're going to solve super hard problems.
So it's not just like generic trust, as in I trust them to not lie to me. You
Right.
actually trust them to deliver on a specific work experience that
Yeah.
you really like.
Yes, absolutely.
That's amazing. I love that. Yeah, I'm
So,
very
as an odd duck, I've ended up wandering from computer science to cognitive science to AI to distributed systems, from engineering to product management, but it all kind of makes sense to me.
companies, big companies, XMLs, APIs, now maybe newer binary protocol, like a lot
Right.
of, I've heard a lot of protocols all over, uh, into the business, into the teams, in like
Yeah, that's right.
it's really a good, it almost sounds like you're an odd duck with a strategy perspective, and it's just that there is not that many people with a strategy perspective.
Yeah, I think it's a set of really simple questions and a big curiosity of like, how do we think together? And that kind of explains everything I do, right? It's all
How
about,
do we sing together?
yeah, how do we think together? That's it.
I'm failing to see the connection. You have to break it
So,
down to me.
so it's distributed cognition, right? So if we build one system, we might interact with that system. But ideally, like in a database or in a cloud system, we're interacting with that system together on purpose. We're building applications on top of it to interact together on purpose.
Mm.
We might not even see each other every day, but the system is offering us messages that represent some kind of collective distributed cognition. So how are the ways that we do that, which all goes all the way from bootstrapping trust, how do we trust each other and the system, to like what is it actually telling us to do, and are we acting in a way that gets the outcomes that we want? So you can kind of wind that infinitely deep, right?
Yes, I was just thinking like it's also like when you design an API, you are trying to send a message to everyone who will use the API around
Yes.
things that are good or bad in your perspective to do. Even you
That was
just
the inspiration, right? It's like, so what if a big company like Walgreens or Home Depot offers an API? All of a sudden, that entire company just becomes a node in your cognitive network. And now
yes,
I don't have to know how to um, distribute pharmaceuticals, right? I can simply make an API call, and all of their competency is now available as a service. But even more so, it's a programmable service. And so one of the best things I've ever heard said was by John Musser in the late 2000s, where he said it's not just the web, it's the programmable web. I think it might have been a Tim O'Reilly quote first, but then he created the programmable
and
web
look
organization.
how
So
soon this
amazing
so,
stuff.
and like, yeah, the curve between like the innovator, like the adoption curve. Uh, Not every company is part of the programmable web yet. We
Right,
know there are going to be.
right,
Like eventually, everyone is going to be that. There will not be a single business who is not API first. I'm a
right.
hundred,
Because the ones that aren't won't be businesses anymore.
yeah,
Right.
because
There is this die-off effect of the evolutionary pressure.
yeah, like, and those API, like by being API first, companies on Shopify
Yeah,
can successfully compete with stores on Amazon, store like with people who sell indirectly to Walmart because they suddenly are open to this huge distribution network. Like if I go to do a gift basket for my employees, for example, or for my customers, I'm not going to go to Walgreens anymore, right? I'm going to look for a service that builds those.
yeah.
And in order for the service to build those, they can only offer things from companies that have APIs. This is the only way they can do it. So, yeah,
Exactly, and that's where the demand's going to go, right? So, I went from learning about this concept of programmable web to working with enterprises to make them more open. And then I realized in 2012, I think with the best writing I did at that time, or talks that I gave, uh, brought it a little bit larger and said, actually, we're going into a programmable world. And the companies that are going to be poised to succeed are the ones that sit at the interface between bits and atoms. So if you are a big company and you can make yourself digitally available, now you can be part of this application ecosystem that does real things, right? Write an API to ship me a bike, right? Or a stuffed animal, or schedule a doctor's appointment, any of the things that I care about. So that I think is the underlying secret of the transformation that we're still in the middle of.
absolutely. So this is super exciting and kind of brings us to something that I wanted to ask you for a long time. Because of all this experience, you've seen so many engineers and so many companies go from, as you said, like I am Target, I'm Walmart, I'm Home Depot, to I'm an API and I'm part of the programmable web. And for the engineers going through that transformation, they must have needed to learn a lot of new things. What do you say, like an engineer who is like, hey, I'm in a slightly legacy company. I need to get to a place where I'm in 2022, maybe even 2025. How do I get there? What do I need to learn? What is the process? What is the journey? Is the word I was after.
Yeah, I think there's three really big things, right? And they kind of follow each other, right? The first is outside in thinking, right? Often as engineers, we are trained and managed to sit within a boundary and either get deeper and deeper in it or to know more and more about the internals of the system and how it connects. You can create a lot of cruft and a lot of strange beliefs, and you can get far from what makes you valuable. So, doing the hard work to get outside in, either take a user perspective by writing applications that use your API or talk to people. That's the first big thing. I had the privilege of leading product management for Firebase when I was at Google. It was already very successful. I had nothing to do with the success. I was just like the uncle who signed some of the checks for it on behalf of other uncles, all the way up to Sundar, right, who ultimately paid for it, right? Um, but what really struck the Google Cloud Platform engineers when they went to the Firebase conference was that every Firebase engineer was a developer evangelist, a developer
Yes.
advocate. Their minds were blown. Like, you're committing code to the Firebase kernel all the time, and here you are giving this talk. Like, why would you do that? And they're like, why wouldn't I? Like, they really manifested that outside in, capability. And so they became very good. So this idea of moving to software as a service goes from your boss being right to the user being right. And you want to help your boss succeed by making the user right, and then everything will work. But you can't follow the traditional hierarchy within this inside out thinking. You have to flip it and go outside in. So that's the first most important thing. I think the second thing that follows on that, once you've adopted that belief, now you have to learn how to think in curves. And here's what I mean. When you just deploy software to a device, the user is paying for the compute cycles. The user pays for the storage, the user pays for the network. If it's not perfect, it's totally not your problem. But once you take the outside and bring it in, you're accountable for all that stuff, and you're accountable for the costs. You're accountable for the latency. You're accountable for utilization. You're accountable for what happens if this thing keeps running for 6 years. And now we have like 10 petabytes of stored data that we don't know how to find or which one is actually useful. So
What happened
thinking
if I have
ahead,
20,000 copies of it? Yeah.
and so nothing's flat and nothing's linear, right? It's all curves. So you have to get really grounded. I'm dealing with a logarithmic problem. Is this a J curve? Is this an S curve? Right? How do I predict what's going to happen over the next 36 months? All your predictions will be
I
wrong.
have to
You'll
dive.
never ever be right, but you have to think in curves and you have to document things that way so that you're anticipating the right shifts in your application and your infrastructure, and that you're a good partner both to the architects and to the product managers. And if you can think in curves, you're well on your way to being a great partner to make a successful business.
I know you had a third thing, but I have to dive a bit because it just feels so important. Like it just highlighted to me, if you are on a logarithmic curve, you are actually like the hard part is over, almost behind you. Like it will soon straighten out and everything will be okay. If you're an exponential curve, just because it's okay now does not mean it will stay okay, and it will start going wrong so fast you won't believe it. How do you know which, like it seems so important to know very early where are you in on that? How do you, like, do you have rules of thumb? Like how do I know where am I?
Yeah, I mean, I think you have to model your expectations, right? You can build models, right? But ideally, a product manager has gotten accountability. Now, that in a big company, that might be a general manager, right? They might just be the founder of your very small company, right? But somebody is doing the job of product management or product ownership, and they have a goal because we're all getting paid here. And so, in order for the paychecks to keep coming, the promises have to be consistent, right? So, somebody thinks that this thing is valuable, and somebody's saying, "Hey, this is a $10 million revenue business this year. Needs to be 30 next year and 100 the year after that." Okay, that's a curve. Now, what does our margin need to be? Okay, that's a curve. Now we can kind of bring that back to like, what is our cost envelope for what we can anticipate in our storage, our networking, and our compute costs? How will this stuff scale? You're at least anticipating growth, and that's the first victory. But detecting the difference in curves has everything to do with making sure you've got competent SRE, making sure that your architects are working with SRE, that you're sitting and reading the telemetry every day, that you've got a clear dashboard, right? Not just measuring your SLOs, but also some of your key indicators, right? Some of your KPIs that are hopefully leading indicators of where the SLO will be. And
And
if you're
also the
looking at it,
business
you won't be
indicators.
surprised, right? I
The
mean,
business
what's that?
you don't, the business indicators too. Like if the revenue drops, it doesn't matter that your availability is 100%.
That's right. Or if your revenue increases and your availability is 100%, but your margin is more than your cost is more than your revenue, also a problem. So again, these are not complicated things, but as an engineer moving into a SaaS environment, we're often bounded into this little silo where it's like, oh, that's not your job. Well, guess what? It is your job. So that's the cool thing about being an engineer in a SaaS organization is a lot more things come into the context that you need to process every day. So it's a more complex, more interesting, more richer job. And it's connected to customer value and it's connected to company value. And that makes our work, I think, really exciting. Customer
Yeah.
value and company value tell you the constraints on where you ought to put your attention. It doesn't matter if you make this one thing 10 times faster, if it's the 10th most used part of your environment that costs 1/100th of your total envelope, right? You immediately have a sense of prioritization once you're thinking curves.
Absolutely.
So the third thing is actually closely related to this whole shift, and that's I would call it project-based life. Not just project-based thinking, but project-based life. Often we have engineering teams who have been built almost as if they're factory workers. So if you go back to the factory revolution, right, in the 1900s, Taylorism, the idea was that as an ideal factory did the same thing over and over, and the ideal worker did the same thing over and over, and we could measure and optimize and improve you doing that one thing. We didn't need you to have context because the system carried the context for you. You got the part, you improved the part, you put the part
Mhm.
back on, somebody else did QA, whatever, right? But there's this factory mentality, doing the same thing again and again. And that's how we come up with job titles. You're a programmer one, you're a programmer two, you're a programmer five, you're a staff engineer, you're a director of engineering. Is that higher or lower than an architect? None of it really matters, right? But we end up trying to figure out how do we pretend that this is factory work? It ain't. It's curious work. All the great engineers I meet are curious. And a project has got an impact, it's got a natural curve, and then it ends. And at the end of that, in project based life, you let go of your attachment to doing the same thing again. Take a few days off, figure out what the next thing is, accept the new thing, get after that, right? So it's this series of curves, not this flat line or this linear graph of like, here's
You're
my career
basically
progression, right?
saying that the modern economy favors Odax. That's what I'm hearing.
It does favor odd ducks, and I'll tell you what. Some of the people who I think had the biggest impact when I had the opportunity to transform and reorganize the platform team at Autodesk, which was about 1,100 people when I was asked to manage it. It was about 700 when I transformed it because I found 400 of the people were not doing cloud. They just happened to be in my cost center. I was like, well, you should probably give them to the folks who they're serving, right? But the people who were the most successful were generally people who could solve at least three problems, right? They could think about user needs. They could think about people in terms of the people who needed to come together to build the project. And then they could think about design and engineering, right? How do these things actually fit together? Often, the people who were the most effective were either um, aspiring directors or practicing architects who could transform their thinking and say, I'm not going to do the architecture job. I'm not going to do the staff engineering job. I'm going to become a product owner.
Yes,
And that was really powerful because actually a senior engineer is an amazingly good proxy for external users. They're very credible talking to external users. They're very good at the underlying pieces of thinking curves. So I'd say anybody who's trying to make this transformation themselves, go and find those aspiring engineers who haven't quite hit director, right? But they've been around and they know what's happening, and create a product owner based organization. And the product owners will be the ones who are the anchors for each of these services that combine to form your whole SaaS offering. But that's real power, right? When they have that intimacy and that drive, and they're curious. Those odd ducks are asking bigger questions. They're not like, look at how fast my code is. They're like, why are we building this?
yes.
That's those are my people.
And in an API economy, the product is technical because it's an API. The user
Exactly right.
may be technical, they may be only slightly technical, like, and there is a
Yep.
lot of, like, in Stripe, they give you the copy paste stuff in case you are not that deeply technical. They make it easy on you. But having a technical person think about the entire experience from the user all the way to the bits on disk
Yes.
means that you don't lose fidelity in the way. And a lot of products are bad because somewhere between this is the user experience, somewhere between the user, the product manager,
Yeah.
and the engineer, a lot of bits got lost.
Always right. You talk about user journey mapping, but that's usually an attempt to reconstruct what that is based on several different people who don't understand each other or the job to be done.
Yeah.
One of the most amazing odd ducks, I love this person, at Autodesk, sent me an unsolicited critique of all of our APIs and the user experience, bringing them together.
Amazing.
I was like, this is amazing. And they joined the team as the developer experience architect. Now that was a heck of a stretch because they're like a principal engineer, right? They're doing really good work. They've got a career path all laid out. And I'm like, give it a shot. Like, you could transform the effectiveness of this whole platform for all of our prospective users and all the people who are using it right now, because they brought that sort of first customer, right? That customer zero kind of mindset.
So we are running a bit at time, and
I'm sorry.
one more thing I really want to hear from you, which is you're a chief strategy officer,
Sure.
and in my opinion, which may be a bit biased by my experience, almost no one knows what a strategy even is. And
Yes.
if we don't know what a strategy is and what it looks like, and we don't even know what it does and why is it important, then the natural question would be, and don't take it the wrong way, please, but what in the world do you do all day, and why do they pay you for it?
An amazing question. I think the title in general is pretty idiosyncratic, right? It changes by company. Product management is idiosyncratic, but strategy even more so. And I do find that there are anti patterns, right, where people hear the strategy and they think it's marketing.
Yeah.
And if you hear the strategy and it sounds like marketing, then it's not strategy. Um, so what is strategy? Strategy is the practice of creating a shared cognitive framework that lets all of us act faster together so we can make decisions that are fast, roughly right, and consistent with each other. That way, as one big group, we can move as one big group rather than as one big group, we can have kind of Brownian motion. And I think there's really three parts to the job. The first is you have to predict the future. We talked a little bit about that before. There is a mechanistic way that you can predict the future in a bounded context by analyzing what's at the leading edge of practice, what's before the leading edge of practice, how quick is it changing, how many people are doing it. It all comes down to your audience. A lot of people talk about total addressable market. I do not start strategy there. I start with total addressable audience. Is it 1 million people that are going to do this differently? Is it 100,000? Is it 10 million? Okay, all of those have different diffusion rates, right? Because you end up with path dependencies and right. So start with predicting the future. It's got to be far enough out that you can make yourself change to hit it, but it's got to be close enough in that you can actually take action on it. So I tend to think 3 to 5 years is roughly right for predicting the future. You can say vaguer things 10 years out, but they're less valuable. After predicting the future, the second thing that you have to do is tell a story. Because the future is really big, right? We're dealing with a thermodynamic equation that takes every available atom in the universe to compute the next state. That's complicated. There's a lot of stuff going on. So a story is a framework, ideally a cognitive frame that narrows the field of care and brings it alive. Okay, so there's the future. So what? Why should I care about it? A
Yeah.
good story brings all of that stuff and makes it really relevant and available for people in a way that feels real today and gives them the opportunity to make a satisfying life for themselves by making choices that accelerate that future. If I do this, well, I get that. Just being awake enough to ask the question gives you agency.
So
But
the story
if we're
has to be actionable.
the story has to be actionable and it has to be vivid, right? So there's a great quote from um, uh, Saint Paul de Exupery. Um,
Mm.
he, uh, he said, "If you want people to make ships, don't stack up wood and give them plans. Instead, fill them with an endless longing for the immensity of the sea." If people get really enchanted with the story, right, they're gonna want to create that future. So predict the future, tell a story, and there's a lot of precision and accuracy that you have to have in the story. It can't be you know, some fluffy thing, right? It's got to be
Yeah.
quite narrow, right? So a story that I tell is about the autonomous future. We are building towards an autonomous future where things like tractors, as well as things like taxi rides, begin to make their own decisions in service of our outcomes. How are we engineering those systems? How are we planning on the feedback loops and what's needed? One of the key things that I care about a lot in this is real-time data. Data's got to get stored. It's got to get moved. It's got to get stored again. It's got to get moved again. How much of that is waste? How much of that is value? How do we compress the waste and increase the value? That's an interesting place to build a company and a technical capability. You can dig into specific examples, right? You can look at Kafka. You can look at Pulsar. You can look at Cassandra. You can look at Iceberg, right? You can kind of bring all these elements as details in your story, but they're highlighting, hey, these are all open source data capabilities that are being connected to create an autonomous future. So that's exciting because autonomous businesses, the ones that you described earlier, they're going to win because when all these things are connected through APIs, you end up with sort of this system of systems, and it's all behaving at line rate. It's going faster than humans can imagine. So it has to have a level of true autonomousness and not merely automation, because automation breaks, but autonomous systems tend to self-heal.
I really love that you talk about just drawing a visionary future in large strokes, but also bringing the detail to it. Partially because the details actually fuel imagination, at least for someone who is my brain, the
Yeah.
details are what I connect with and excites me. But the other part is that I can imagine when you said teach people to long for the sea, I try to imagine telling my engineers to long to the sea, and I know what's coming. How fast is the wind? How often do the currents actually change? How deep is it really? What is the mean temperature? What is the variance? Like, and they need the details because if you don't have those, you don't know what to build. It suddenly the story is a lot less actionable because it could be anything, as you said, like there's infinite number of atoms
Yes.
interacting.
And the lack of detail can be lethal for you as a company, because if you pick a technology or if you develop a technology that's targeted for the wrong order of magnitude of complexity,
Yes.
right? If you think this is only going to need to run at terabyte scale, but really it's going to end up running at petascale, and then you look at the way that you're doing consensus, and you're like, shoot, it's going to be the heat death of the universe before this thing converges. And we've got 100 customers already on the system, and they're all growing, and they're all going to have these sort of catastrophic successes where the successful business is storing more data, but it's a catastrophe because the algorithms don't scale. Like you absolutely do need to be in the details. I mean, look at the transition from Apache Hadoop, right, to Apache Spark, right? That ended up being an algorithmic complexity distinction that helped one thing win when you got to that success criteria where you're storing lots more data and have a lot more users trying to ask questions. So this is life and death, right? Getting the right story with the technical depth as well as the heart and the mind that inspires. You got
Yeah.
to get that right.
And the big part of the story, if you look at Spark, they saw that S3 is going to be ubiquitous. And it
Yes.
lets them make the bet on it and
Yes.
not invest a lot in HDFS, which turned out to be on the down curve. And I
Yes.
think like being able to say, okay, how do you know that S3 is the future? Because it has APIs, because it's serverless, because it infinitely scales, because it abstracts away 100% of all the complexity in the world,
Mm-hmm.
essentially, because it integrates with tons and tons and tons of other things. Every security protocol you can probably possibly imagine. It's not just Kerberos. Like those things matter.
And
Oh,
that goes back to thinking in curves. You can use curves to predict the future, right? So if you take some of the lessons that Bill Gates taught Microsoft, right? If you think about curves on a 10-year scale, you can make a bet on the right architecture, right? He bet against HP's Itanium and in favor of x86 because he looked at the raw number of x86 chips that were going to go into the market, and there was no way that Itanium was going to be able to retain its superiority for more than a couple of years. Fear, it's the heart of hope, it's the heart of kindness, is to make sure that people can make decisions that tend to get them where they want to be, right?
yes.
Not every decision is perfect, not every life is perfect, but if we can give people agency, then they can make better decisions because the strategy is better founded. We've predicted the future with good math and curves. We have told a story that makes even these very complex truths much more accessible. And the third piece of strategy is turning them into decision frameworks, making sure the decisions can be clearly cascaded so that each person or group that's competent to make a given decision, no decision's perfect, but make sure that you're pushing to the maximum degree possible a simple story into a rich framework where people make decisions fast at scale, and those decisions are to do something and to not do something else. The opposite of strategy is something I've experienced for from some executives and teams I've worked for, where on Monday the strategy is A, Monday night the strategy is B, Tuesday morning the strategy is C, and Tuesday afternoon, why haven't you done A, B, and C yet? And often it's a misunderstanding of the fundamental topology of how the code works, about how fast we can get anything done, and you really do have to pick A or B or C. You cannot do all of them and call it a strategy. And often that's a failure. So you have to make decisions. You have to make as many decisions as you can at a high level, because that's kindness. You don't want everybody boiling the ocean and refiguring out all this stuff. And then you want to push everything as far to the edge as possible. So to me, strategy and being the chief strategy officer is you have to be a master of the medium you're in, right? You wouldn't trust a painter who didn't know how oil dried, right? You really have to spend a lot of time being curious about how these things actually work. Based on that, you can predict the future. Based on that, you can tell a story. And based on that, you can provide a decision framework. If you've got that, you're probably going to be in pretty good shape.
And it sounds like you're really connecting the top level thinking at the company level, because you are an executive, with a lot of the bottom up um, drive that people in the company has. So you can really,
Yeah.
once the strategy really utilizes this drive, that's kind of where magic really happens. And you've
Yeah, and it's got to be based on curiosity, right? Like it's the core strategies. It's got to be science. It can't be politics. Everything has to be testable. The decisions have to be testable. They have to be iteratable. You have to be able to roll it back. So once you've got it working, you've got it working because you've asked a lot of questions. And as it continues to work, and the world changes and technology changes, you keep asking questions, and you encourage everybody to ask questions. And that converges faster than anybody would expect if you create permission for everybody to ask, well, why is this way? So I guess that brings me to the beginning. Like I was asking why a lot when I was 5, and so my mom got me an encyclopedia, and I keep asking why, and I'm a chief strategy officer, right? So this is
cannot let you go without some future predictions. And I'm going to
oh
actually
sure.
write them down. So in 5 years, we will come back and check what happened to the world.
So I'll offer this as quickly as I can. So I think predicting the future starts with where we are today, right? So we've just finished the 3rd season of a podcast that I get to host called Open Source Data, and so I'm just asking curious questions of really, really, really capable people who have built stuff, right? So they have a right to an opinion because they've done it the hard way. They've written the code, they've tested it out, they've seen people use it, they've seen it fail, and they know stuff. So we have a dozen people per season, and so I've just listened to a dozen really, really sharp people in season 3. And there were 4 really big trends there. The first one was shifting left on data. And this makes a lot of sense. Again, thinking in curves. There's just not enough data centric people to do all the data tasks we have. So we need more automation, more autonomy, more autonomousness. So, how do we get more developer productivity around data? Really interesting and curious question that a lot of people are not asking. But if
Data
we think
developer.
about what it,
Yes.
well, if you think about what is the Git for data, right? I see your axolotl from Lake FS, right, which is kind of building a Git capability for data. What's that ecosystem look like? Or is it going to be Apache Iceberg, right? And some of the stuff that Dremio is doing, right, with Project Nessie and Aeroflight. But shifting left on data is like a really clear trend. Another clear trend is open source means scale. If it's not open source, you generally don't trust it, and it is open source because it's already been built by a hyperscaler, right, or an internet scale company, right? Just like Kafka came out of LinkedIn, right? Just like Pulsar came out of Yahoo, just like Cassandra came out of Facebook, right? All these technologies increasingly have come out of companies that were using them at enormous scale, and then they start meeting the market. They get a little bit more customer useful, but like if you think about open source data, you're thinking about like this is a scaled architecture. It's something that can connect well, and each component understands, what its scalability limitations might be. And I know this is an area that's near and dear to your heart.
Yeah, no, it's just like there's just so much to take in. I'm just
I
like,
know, I know sorry. Uh, so there's two other key trends that I saw this season. One was really responsible data. People are now becoming generally aware of how much power there is in data. So what are our ethics? What are the questions we're asking? And how can we not just get the provenance of data, but how can we trace how it's being used? Because we want to be responsible as we create a data mediated digital experience for most human beings. And when you think about how many human beings are building the platforms, a few million, how many are depending on them, a few billion, our responsibility is our leverage, right? It's multiplied by how many lives each of us touch, right? How are you taking care of people's lives,
yes,
and what can you anticipate the future? And then finally, AI first is probably the most fascinating thing, right? There's now like an AI first stack when you think about um, things like embedding hub, right? Embedding databases. When you think about producing vectors from models, where do you store the vectors? When you think about doing vector search, right? There's a whole new way of thinking about AI first architectures. Much like cloud native was amazing 10 years ago, AI first is kind of that new
And you
amazing.
feel like this is a thing that is kind of doable now, like because we've been talking about AI forever. I mean, literally forever, like probably since the 50s. But then, like I don't know, since 2010, like the rise of big data and everyone bigger questions, everything is AI. But it it was very successful if you look Facebook, Google, all those. But like normal companies did not quite manage to get there. And like normal
Right.
companies, I mean anything from JP Morgan Chase to maybe a small startup that is, just as an example, trying to do a control plane for SaaS. So
Exactly.
do you think now the technology is there that I can actually use it? It will not be like a huge waste of effort with a lot of premature stuff for, because I am not an expert.
Yeah.
I didn't hire any experts. Is it okay for normal people to dabble with AI tooling? Are they ready for us?
Yeah, I think for sure, and I think it's also still early, right? So I mentioned I
Yes.
got my degree in AI and neuroscience in 1994, right? So that was the second AI winter that I graduated into. So we've talked about AI for a long time, but we talked about technical path dependencies before, right? So S3 was something that you mentioned. The fact that we can now start to standardize on S3 is pretty powerful, and I'll talk about that in terms of the three trends I see coming. But I do think that if you want to play around with something like SageMaker or
Mm,
Snowflake's AI stuff, right, or Microsoft's AI stuff, it's kind of all in one. It's not exactly a toy, but it is a monolith. So that simplifies complexity, but it means that you can't do as much. Great first user experience, probably not the best expert user experience. So I do think that's safe. Um, a lot of AI technologies are still in rapid evolution. If you talk to anybody who's in the environment, whether they're doing something operational like Kubeflow, or whether they're doing something like feature stores, or like Feature Form or Tecton, right? The space of practice of the human beings is still changing pretty rapidly. So remember, I said I don't believe in total addressable markets. I believe in total addressable audiences. Is the human practice settling down? No, it is not yet settling down. It's increasing, and the variability is increasing, and the complexity of the architecture is increasing. And the last project that was amazing, Feast, is now kind of already getting less amazing, right? And there's a new
I
thing
missed
coming along,
the last amazing project.
right? So you can kind of look at the flux, right? What's the rate of change? Just like you predict a software release, is the rate of change starting to settle down? Not
Mm,
yet. When it starts to settle down, I would give you a different answer. So that takes me to my three trends that I'd offer for the next 5 years. The first is practices that bring ML ops and DevOps together will be dominant. Those are the most important things, they're the most value creating, and they're the most broken right now because we do these very, very fast application cycles. And these slower cycles to data ops and slower cycles to ML ops and then cycles to model ops to the point where we're putting, in some cases, people are putting notebooks in production.
yes.
They're like, okay, we have this amazing mainstream strategy. We've got an infrastructure you can just drop Jupyter notebooks into and it will scale. No, honey, it won't. Like it really won't. You might be able to run that individual notebook, but that is not what the spirit of DevOps, continuous improvement, continuous deployment is. It's about each artifact being part of a system of people who know how to work together. It's about the consistency of the artifacts. Can we rewind, right, what's in production? Well, that gets really, really hard with ML because there might not be anything broken with the model. The data might have broken. So being able to get this cycle all the way back into DevOps and make a really short iteration cycle from new idea, new app, new experience, new model iteration, new data. That's kind of absolutely got to get nailed. Some companies are doing it amazingly well, and those companies are growing at a ridiculous rate. So that will be the dominant pattern, I think, 5 years from now.
Yes. That was one. You said there's three.
So the second thing is an open standard for data access. You talked about S3, and I think that is amazing, right? So I had the privilege of working with the Kubernetes team when I was at Google. And that thing has just taken over the industry at a rate that none of us expected. Um, that was the ability to start separating and moving compute around.
Yes.
And then you look at what Snowflake has done, which is genius, and they describe it very simply. They say we've separated compute from storage. Oh, that's great, because every hard problem in computer science can be solved by delayering. So separating compute from storage is amazing. So for compute, we've got Kubernetes. For storage, we've got S3, right? We started to simplify and say, well, object storage is kind of the thing, right? Is that going to be Minio? Is it going to be something that EMC comes up with? Like, what's going to lead that market? I think none of us knows. But some of the affordances of that storage will be essential, both for things like, LakeFS or Dremio, right? The ability to, or Databricks' Delta Lake, the ability to do versioning of different sizes of artifacts gives you the ability to do rewinding, right? That's the only reason you version, right? Is so that you can play well with each other in a bigger group. But one of the biggest problems we have is we have a tremendous amount of waste, right? If you think about the architecture diagram that you offered earlier this year, I see a lot of data moving around and being read and moved and written and read and moved and written and read and moved and written. It's like, oh my
Yes.
God. Um, when you look at the capability of the companies being built on this, we're going to be using more and more electricity to move data around than we do on vehicles.
Yeah. Is it? We
So
probably
how do we collapse that complexity, right? An open standard for data access might look like something like Apache Arrow or Arrow Flight. Some way to say we've got self-describing data that assumes that it's sitting on an S3 style bucket, that the S3 API becomes the standard, and that we can quickly either read it in place with a zero copy query, or we can move it in a memory format on the wire that can go into your compute environment very quickly without you having to sort of recatalog, reindex everything. So you have to look again
I mean, you
a
think
few
about
years ahead on the curves. It starts to look like you have to have an open standard for data access that looks somewhere like Kaitai and S3 and Arrow or something like that.
it's not just the standard for the data querying, which you're right, like where they find the data needs standardizing, and the formatting of the data and the memory format and all those absolutely need the standardizing. I think also permission models on data need
Absolutely.
standardizing. If I go to S3, I have one set of permission model, courtesy of IAM. If I go to Snowflake, it's SQL. I know how to do grants. If I go to Datastax and I want to share my columns, I have no clue how to share them. I'm
Yeah.
sure. I hope you didn't invent something yourself, but you probably did.
No, there's stuff that's native to Cassandra, but you're exactly right. If we're
Yeah,
talking about open standards for data access, it has to also being watch who should have access and
yeah,
who did
exactly.
access and
The
being able to audit it.
access part is really important. Like the access controls part
Yeah,
is part of it. The authentication, like there is, I think, two, three big standards in the world for how to authenticate the stuff. Databases currently support neither. Can we try to get aligned
right.
between APIs and data access? Like this is still like I can see what you're saying. Like it feels like the early days of how do we bring all this data together.
And in the middle, there's waste, right? So
Yes.
if you can solve this, you can imagine how fast companies and organizations, governments, whatever, teams could move. But if you can stop copying it all the time, and you can get immediate access to the written data. One of the interesting things that we found is you can write a production database on S3
No way.
because production databases really run in memory. And so when you
Okay.
think about the compaction step, you can quickly and in parallel compact to S3, and then you can give that access to analytics. So you can have kind of a real time analytics path where you're not waiting for copies of copies of copies, but you could point analytical systems models at the just written data. That starts to get like really powerful and really interesting. But also those people who are building the models, they can't be asking for permission all the time. Like you go to a microservices team, you go, I know you have the data for all of our customer logins and what system they accessed. I need that so I can figure out where we're having the most trouble or where we can create a new product.
Yeah,
Okay,
just
well,
permission flows are a big deal now because you don't want to give everyone all the access to all the data, right? It's
right,
huge privacy concerns, huge moral hazard. Like this is
sure,
like your company will not like your engineers will not even be able to trade their stock because everyone has the access to all the company information. So you do need
Except
to
they,
control, but you don't want it to be slow. It has to be
exactly.
autonomous.
I completely agree. So not only will they be in trouble, but they hope to be able to get the chance to be in trouble. It's more likely that your request for data will be like, oh, we need to modify the API. Oh, it's just an internal data science team. We'll put it on the backlog,
That's
and
a problem.
and then you get it in 6 months.
Yeah, that's a big
So
problem.
one of the things that Vince Cerf talked about, he's a Google fellow now, and of course one of the co-inventors of TCP/IP along with Bob Kahn. He talked about permissionless innovation. So I think about this a lot in terms of the power of standards. When I say open standard for data access, really enabling permissionless innovation across a given company by interested parties who have the business interest at heart. They should be able to get at it quickly. And then
Yes.
we also need an environment with automated guardrails that can say, hey, this looks like anomalous access, but it should happen a bit after the fact, right? Because you want people to go in and innovate.
Not
So that's
necessarily. Like if you're in Europe, you have so many regulations. Your marketing people should never be able to look at anyone's personal information.
right,
Like never ever. Your support people are allowed to do it.
right.
There may be like an extreme case where you do need a marketing person to do it. Like I think that if
Right.
you want to allow people to get the data they need for good reasons when they
Yep.
need it in a very auditable way. So if an auditor asks, why did this marketing person looked at this information? I want your SOX audit. Well, how do you
Totally.
do governance? You should be able to say, oh, it was approved by this person for this business reason. And it can all be made simple. Like it can
Yes.
be, I click, I need access. Something pops up on my on the manager's phone. Hey, this person needs access. Here's the
Yeah.
business reason. You click yes. That's it. You're done. It
Yes.
doesn't.
And then you could say yes, access, and then it says this is PII. Really, really? Or do you want to give them the homomorphically encrypted version, which
Yeah,
is mathematically identical and will enable them to do their job without ever violating PII? Right.
exactly. And
These are the
so
things that have to become obvious. And so when we think about open standards, right? OASIS was a standards body, right? IETF is a standards body. You start to think about standards as ways that we can pool a lot of collective competency and intellectual property and make it free.
exactly.
So that's what I mean when we say
Like
open
none
standards for
of
data
this
access. There's a lot of stuff
ideal
going on in
experience will never happen without standards because you said you just get stuck. By the time someone finishes writing the API, there will no longer even be in a place to ask, okay, so how do we give permissions?
That's exactly right. And maybe writing the API is the wrong thing. It should be an auto-generated API, or they should have automatic access to the S3 buckets, and they should be
Yes.
able to say, "Hey, point source, give me that as a Parquet file," or "Hey, point source, give me that as a Arrow Flight endpoint." So that takes me to the last piece, which is this autonomous future, right? So none of these good ideas matter unless the economy is pulling it. But look how the economy has rewarded autonomous companies like Uber, right? Making automatic matches constantly, and the system gets better by itself, but it
Yeah.
partners with people, much like a horse and a rider, right? TikTok is an autonomous business, but they're not strictly digital, right? TikTok's mostly digital. Uber is kind of digital physical. And then you've got companies like John Deere, which are now transforming their businesses to say, like, we will sell you farming services. And these are digital services that will let you say, I want to have X yield on Y plot, figure out how that can happen, and then monitor as these tractors are moving back and forth, driving themselves, by the way. What is the actual sensed reality, and how do we need to make changes? Autonomous businesses have the ability to scale demand side efficiencies faster than anything we've ever seen. So they tend to uh, winners take most effects. It's not first mover, that's different, right? But winner takes most to winner takes all. So autonomous businesses 5 years from now will dominate the economy, and you will start to see the same shifts we've seen the last 10 years with platform companies starting to take over the Fortune 100. You'll see this shift towards autonomous businesses, and they'll be characterized by companies that have figured out how to do open standards for data access, and they will have figured out how to connect DevOps and MLOps in a coherent loop. So those are my three predictions: practices that bring MLOps and DevOps together, open standards for data access, and an autonomous future with an AI native stack and AI native thinking.
Amazing. That's like we're announced in the future. And it seems as you have a definite talent to creating those detailed stories that make it look real. Because I feel like I've been there already.
Thank you so much. Well, I think, for the other odd ducks out there, you'll see there's a lot of business books, but the middle stack is all Dungeons and Dragons. And those are really thick rule books, and that's just the fifth edition. Like I and many other people have read every single edition and argued about them. So there is something powerful about being able to completely subsume rules-based systems and then tell interactive stories with each other about them. And I think there's a lot of demand for us odd ducks and nerds.
Chief Strategy Officer as the DM. I think my life has just changed.
I have described my job as actually being the DM of the company.
This is way, actually, it's a better title. I would strongly consider.
Oh, Gwen, thank you so much.
So much for being here. It was a great conversation.